Assalamu alaikum. In today's lesson, we are going to discuss the industrial applications of electrolysis process. So first we are going to discuss the electrolytic refining of copper, that is how the pure copper is obtained from the impure ore of copper. We know the importance of copper metal. It is a good conductor of electricity and heat, and industrially it is mainly used in electrical wires, and it is also used to make the base of the cooking pans. This is the electrolytic cell, and it shows that impure copper serves as an anode or the positive electrode. It is thick because of the impurities attached to it, and the pure copper serves as a cathode or the negative electrode, and it is purposefully made thin because the pure copper from the anode, it will come and it will get attached to the cathode. These are the reactions taking place at anode and cathode. At anode, where the impure copper is there are impurities like zinc, iron, silver. The copper gets oxidized by losing 2 electron. It forms the copper ion, Cu2+. And at cathode, the copper ions, they get reduced by gaining 2 electrons. It will form the neutral copper, and this neutral copper, it will get deposited on the pure copper. The electrolyte used here, that is the acidified copper sulfate solution. Few drops of sulfuric acid are added in the aqueous solution of copper sulfate to make it a strong electrolyte. And it is shown this aqueous solution of copper sulfate, it is shown with the blue color because copper sulfate is a blue salt and its aqueous solution is also blue. That's how pure copper is obtained from impure ore of copper. Thank you for watching. So here we have another industrial application of electrolysis process, that is manufacture of sodium metal from fused molten sodium chloride. This is the electrolytic cell that is used to make the sodium metal from fused sodium chloride. This is called down cell, and here the anode or the positive electrode, this is made up of graphite, which is carbon, and the cathode, the negative electrode, this is made up of iron. This is the opening from where the fused or the molten sodium chloride is added. At anode, the oxidation of chloride ion takes place and chlorine gas is made, and it comes out from here, from this center of the cell. And at cathode, the sodium ion, they are reduced by the addition of electron, and they form the neutral sodium, and the sodium metal that comes out from here. The positive anode and the negative cathode, they are attached to the voltage source or the electricity source. And here are the reactions which are taking place at cathode. The reduction of sodium ion, Na plus, by the addition of 1 electron, it is converted into neutral sodium. At anode, the oxidation of chloride ion taking place. It is losing 1 electron, the chloride ion is losing 1 electron, and the 2 neutral chlorine atoms, they are making the molecule of chlorine Cl2. And anode, as we discussed, it is made up of graphite or carbon, which is a neutral electrode, because at anode the chlorine gas is made, so neutral electrode doesn't react with the chlorine gas. Moving on, here we have another industrial application of electrolysis process, that is manufacture of sodium hydroxide NaOH from brine, which is the concentrated solution of sodium chloride. The electrolytic cell that is used for the production of sodium hydroxide from brine, that is called the Nelson cell, and this is the design of Nelson cell. The anode is made up of graphite or the carbon, and the cathode is made up of perforated steel. This is the cathode, which is the perforated steel. Perforated means it has pores in it. From this opening, the brine or the concentrated solution of NaCl is added. The sides of this electrolytic cell, they are made up of heat resistant material, asbestos, and this is the opening from where the steam goes out, and at the base the sodium hydroxide deposits. These are the reactions which are taking place at anode and the cathode. At anode, the oxidation of chloride ion is taking place. We know that in the concentrated solution of sodium chloride, there are two anions, Cl negative and OH negative, that is the hydroxide ion. But as the concentration of chloride ion is more, so chloride ion is going to get discharged at anode. So it is going to lose the electron and it is going to make the neutral chlorine atom, and the two chlorine atoms, they combine and they make the chlorine molecule Cl2. The cathode, the cation H plus, it will get reduced by addition of electron and it is going to form the neutral hydrogen atom. The two hydrogen atom, they combine chemically, they form the covalent bond and they will make the molecule of hydrogen gas. The two ions which are not discharged, that is the sodium ion and the hydroxide ion, they are going to make the sodium hydroxide which settles at the bottom, and the byproducts of this electrolytic cell, which are the hydrogen and chlorine gas, they are also used industrially. Thank you. Here we have another application of electrolysis, that is electroplating. It is coating with a thin protective layer of metal. A surface that is likely to corrode is protected by a thin layer of a metal. This is called electroplating. So if iron has a thin layer of zinc on it, this is called galvanized iron. The metal that is to be coated acts as a positive electrode or the anode, and the object that is to be coated acts as a negative electrode or the cathode. The electrolyte used here is the solution of the salt of the metal that is to be coated. Here we have example of coating iron nail with copper. The copper coin acts as a positive electrode and it is connected to the anode, and the iron nail acts as a negative electrode and it is connected to the cathode. The electrolyte is the blue copper sulfate solution. So if we want to coat the iron nail with silver, then we would be using the silver coin and we would have the electrolyte which would be the some soluble salt of silver. And industrially, the car bumpers, they are also coated with the thin layer of chromium metal on it, and then in that case the car bumper would serve as a cathode, the negative electrode, and the chromium metal would be the anode. So in this case, where the copper gets deposited on the iron nail, these are the reactions, half reactions taking place at anode and cathode. At anode, the oxidation of copper taking place. Copper is converted into copper ions, Cu++ by losing 2 electron, and at cathode, the copper ions, they are reduced by gaining 2 electron, and this copper will get deposited on the iron nail. Thank you.